We were on the phone with him. He was like, so what's your friend think about?
Did we get our spreadsheet
All right, graphing quadratic functions in vertex form, intercept form, sorry. Intercept form is f of x equals a times x minus p times x minus q, where p and q are the x-intercepts. Okay, so in our first example, we're going to have to identify lots of different things from the function. And the good thing about intercept form is that a lot of what we need can be found by direct observation. In the function, f of x equals 1/2 times x minus 2 times x plus 4. I want you to notice that this function is in its factored form. It's not in standard form. It's not in vertex form. It's in intercept form, which means that the function has been factored. And when we've got it in factored form, the intercepts are what we would call the zeros of the function. They are the x values that satisfy the function. In other words, they are also the x values where this graph crosses the x-axis. Now, we're going to identify a, p, and q from the function itself. So the a value is just like before. It is that leading coefficient. It's that number that's in front of in the very beginning of the function. So 1/2. 1/2 is our a value. The p value is one of our x-intercepts, and it really does not matter what we call p or q. The order does not matter. The p value and the q value are going to be the opposite of what's inside parentheses. So what's the p value? I usually say that the p value comes from the first set of parentheses. So the opposite of -2 is 2. The q value will then be the opposite of the second set of parentheses, -4. The x-intercepts then are what we would call 2, 0 and -4, 0. And the reason we include the 0 is because these are the actual coordinates of our x-intercepts. These are the coordinates where the graph crosses the x-axis. These 2 points are actually the roots or the solutions or the zeros of this function. These are probably the most important parts of this function, because wherever the graph crosses the x-axis, there you have the roots of that function. Now, I'm going to skip axis of symmetry for a second because we can't find that until we find our vertex. So the vertex is determined by a little formula, just like we had a little formula for standard form. We've got a little formula for vertex form. This is the formula. P plus Q divided by 2 will give us the x value of the vertex. It's really kind of an average of these 2 values. You add them together, divide by 2, that's like an average. It's going to be 1, or -1. It's going to be P is positive 2 plus -4 divided by 2. That gives you a -1. So our x value of the vertex is -1, which means that our axis of symmetry is also -1. Now we can find the y value. We're going to do it the same way we did for standard form. We're going to take this x value and we're going to plug it back into the function. So -1 gets plugged in everywhere there's an x. So we're going to have -1 minus 2, and we're going to have -1 plus 4. Now this time I did not put an extra set of parentheses around the -1. And I didn't do that because I just don't want there to be a bunch of parentheses in this problem. It just kind of gets cumbersome. So then we simplify. So what's -1 minus 2? -3. And what is -1 plus 4? 3. What's -3 times 3?
9.
-9. And then half of -9 is what? -4.5. So our y value is -4.5. So we've got our vertex, we've got our axis of symmetry, we've got our x-intercepts. The only other thing we're going to answer is whether it opens up or down. Does this open up or down? It opens up because the a value is positive, just like with the other forms of the functions. So now we've got everything we need to graph this function. We've got our 3 points already determined. The vertex is one of our points, and then the 2 intercepts are the other 2 points. So graphing this is going to be very easy once we've got all of this stuff filled out. Okay, so our function again was 1/2 times x minus 2 times x plus 4. And you should have all of the other aspects of this, the important material in your notes. So now we're just going to graph it. Now, used to, we always graph the vertex first. But once you've found all this information, it doesn't matter what you graph first. However, it is important that you put your axis of symmetry through the vertex. Now, what was our first x-intercept? 2, 0. So that's to the right 2. And then on the x-axis, because if 0 is the y value, it's on the axis. And our x-intercept has to be on the axis. So there's one of my points. Where's my other x-intercept? -4, 0. So go to the left 4, and you're on the x-axis. And then my vertex is -1, what? Okay, so I'm going to go to the left 1 and down 4.5. Left 1, down 4.5. 1, 2, 3, 4.5 would be in between 4 and 5. Now, once I put my vertex, understand the vertex has got to be between the intercepts. The x value of the vertex is just the average of those 2 x values. So it's right in between. So then I draw my axis of symmetry down through the vertex and then graph the curve, and I'm done. So I don't have to worry about my reflection. I don't reflect anything because I've already got all 3 of my points. In standard form and vertex form, we had to reflect the second point to get the third point. In intercept form, we don't have to reflect because we already have our intercepts and we already have our vertex. So we've learned 3 methods. We've learned how to graph from standard form, we've learned how to graph from vertex form, and now we've learned how to graph from intercept form. Intercept form is the form that deals with the factored standard form. So if you took standard form and you factored it, you would get intercept form. And intercept form is good, beneficial for us because it shows us where the solutions are. Your solutions of a quadratic function, of any function, are always where the graph crosses the x-axis. That's extremely important for you to know when it comes to algebra. Your solutions are always where the graph crosses the x-axis, period. All right, so you've got an example, and we're going to do more examples as we proceed.